Hello everyone, welcome back to Automation Engineer channel. Today I will introduce to you about an industrial communication protocol that's named ASI and how to program for it with the PLC S7 1200. Firstly, what is the ASI? The ASI stands for Actuator Sensor Interface. This is communication protocol for the lowest layer in the automation pyramid, the field device. And you can see the automation pyramid here. You can see here. And this is the ASI network. The ASI is created for the purpose to connect the sensor and the actuator with the low cost for the material and installation. Also easy for operation and maintenance. So the main characteristics of the ASI is below here. First is about the ASI cable. It's used both for data exchange between the sensor actuator, this means the ASI slave, and the ASI master, and also for the power supply to the sensor and actuator. The second is about the data transmission methodology. This is reliable in the industrial environment, but no need high transmission bandwidth. And the third one is about simple and the cost-effective wiring. This is about the wiring. The simple installation with the penetration technique, high flexibility with the 3-line wiring. And the next one is the fast reaction time. The ASI master requires a maximum of 5 milliseconds for cyclic data exchange with up to 31 nodes. Okay, next one is about the nodes. This means the ASI slave on the ASI cable can be a sensor or actuator with an integrated ASI connector or ASI modules. With up to 4 conventional binary sensor or actuator can be connected. Next one, with the standard ASI modules, up to 124 actuators or sensor can be operated on the ASI cable. Okay, next one, if you use the ASI module with the extended addressing mode, up to 240S actuator and 240S sensor can be operated with one extended master. Especially when using the profile S7.AA with 8 input and 8 output, up to 496 actuator and 496 sensor can be operated. Okay, that's the definition. So next we come to the ASI network component. In ASI network we have total 10 components here. First is the ASI master. Second is ASI slave. We can divide into 2 types. First is the ASI module. The second is a sensor or actuator with an integrated ASI connector. Third one is ASI cable. Next one, ASI power supply unit. Next one is addressing unit, diagnostics unit, and also the SI analyzer, another name. Next one is about a safety monitor and repeater, extender, And the final one is extension plug. And this is a basic SI network with almost component. Okay, I will go detail a little bit here. Firstly, we have the PLC, the main controller of the process. And this is the SI master. And this is the power supply for the SI slave here, and also supply the power supply for some few device here. And this is the additional power supply. This will supply the power for some actuator, the motor, the valve here, which is using the higher power. For example, this pack can use the power is 220 voltage. Okay, next one, this is the SI slave. This means the IO module here. And this is the repeater. And this is the extension plug. And we have a lot of few device here. Okay, detail of each component I will show you now. Firstly, about the SI master. We have two types of SI master. The first is the standard master. Up to 31 standards SI slave or SI slave with the extended arresting mode. Only 8 slave can be connected to the standard SI master. Standard SI master are available for connecting to the system. Simatic, S5, S7, C7 distributed I/O, Simulation C, and you can see the physical picture here. You can see. The second type is the extended master. The extended master support 31 address. That can be used for the standard SI slave or SI slave with the extended addressing mode. SI slave will with the extended addressing mode can be connected in pair. Program SA or P slaves to an extended SI master can use the same address. This increases the number of the addressable SI slaves to a maximum of 62. Extended SI master are available for linking to the system Simatic S7 distributed I/O. Okay, you can see the physical picture here. Okay, next is SI slave. We have two types of SI slave. Sorry, I typed the wrong word here. This is the slave. The first type is the SI modules. They are the SI slave to which the sensor and actuator can be connected. The second is the sensor and actuator with the integrated SI connector can be connected directly to the SI interface. Okay, this is the one example for the SI module. Okay, next is about the power supply. You can see the SI power supply normally is 30 voltage. Supply the power for the SI not connect to the SI cable here. And for the sensor or the actuator with a higher power requirements, an additional power supply, for example 220 volt or 110 volt may be necessary for this device. And next is about the cable. The SI cable is the type of unsealed two-wire cable. It transfers the signal and supply power for the sensor and actuator connect using SI modules. Network is not restricted to one type of cable. If necessary, appropriate module or the T-piece can use to change a simple 2-wire cable. Okay. Okay, next is a repeater. The function of repeater is extend the capacity of the SI by extending the SI segment and also providing more capacity in the system. The downtime and the service times can also be reduced because the SI power supply is displayed for each side, separate the power supply. The further feature of the repeater include some is first is like can be used on the both sides of the repeater. The second, the electrical isolation of the two SI profile cable lines. The third one is a maximum of 2 repeaters can be used in a series. Max cable length to 300 meters. And the final one, the parallel connection of the several repeaters is possible. Style configuration possible. Okay, next is extension block. When using the extension block here, the maximum possible cable length in the SI segment can be double from 100 to 200 meters. The extension block is a passive component and is connected to the part of SI network from the power unit. Only one power unit is required to power the slave on up to 200 long segment, 200 meter long segment. Okay. Okay, next is some further component. First is a resin unit. It allows a simple programming for SI slate addresses. Here, this is the picture of the resin units here. Next is extender. The function of extender is extend the distance between the master and the ASI segment to a maximum of 100 meters. On the master side, however, no extra power supply is required. An extender expands the possible use of the SI is much the same way as the repeater. Here, the slave can only be used downstream for the extender. The feature, some further feature of the extender is first one, extender with the repeater connect in parallel. A cable length significantly longer than 300 meters can be achieved. The maximum span is 500 meters. The second, a master can be located up to 100 meters from the actuator, the actual SI segment. And the final one, no electrical isolation of the two SI profile cable lines. Next one, the diagnostic unit. It's used to test the SI network. The troubleshooting is made systematic and permanent monitoring is much easier. The ASI analyzer also allows documentation for the commissioning and the service by creating a test report. Here you can see this is the picture of the diagnostic unit or the ASI analyzer, and this is the position of the analyzer in the schematic of ASI. Next one is the safety monitor. This is the host of safety at work. You configure a safety application on the PC with the safety monitor. Okay, that's the on component of ASI network. Now we come to the configuration parameter. First is cycle time. With the standard ASI slash is maximum 5 milliseconds. And with the ASI slash using the extended addressing mode, is maximum 10 milliseconds. SI use a constant message length complicated procedure for controlling the transmission and identifying the message length on the data format and not required. This makes it possible for master to pull on the connected standard slash within a maximum of 5 milliseconds and to update the data both on the master and the slave. If only one SI slave using the extended addressing mode is located as an address, this slave is pulled on at least every 5 milliseconds. If two extended slaves A and B slave share an address, the maximum polling the cycling is 10 milliseconds. The B slave can only be connected to the extended master. For time critical applications, 16-bit input and output data can be transferred in a maximum of 5 milliseconds. To achieve this, the transmission bandwidth normally used by up to 4 SI slaves is used for one slave. Next is slave quantity. The standard SI slave maximum can up to 31, and with the SI slave using the extended addressing mode can be maximum 62. SI slave at the input and output channel of SI system. They are only active when called by SI master. They trigger action or transmit reaction to the master when commanded. Each SI slave is identified by its own address from 1 to 31. A maximum of 62 slaves using extended addressing mode can be connected to an extended master. The pairs of slaves using the extended addressing mode occupy one address. In other words, the addresses from 1 to 31 can be assigned to two extended slaves. If the standard slaves are connected to a standard master, these occupy a complete address. In another word, a maximum of 31 standard slaves can be connected to an extended master. Next is about the input and output quantity. With the standard SI slave, maximum 124 inputs and 124 output. For the SI slave using the extended addressing mode, can maximum 496 input and the same for the output. Each standard SI slave can receive 4 bits of data and send 4 bits of data. Special module allow each of these bits to be used for a binary actuator or a binary sensor. This means An SI cable with the standard SI slate can have maximum of 240S binary extraction, include 124 inputs and 124 outputs. On a typical actuator or sensor can be connected to the SI interface in this way. The modules are used as the distributed input or output. If the module with the extended arrangement mode are used, a maximum of S inputs and S outputs is available per module. In other words, a maximum of 496 inputs and 496 outputs can be operated with the module using the extended arrangement mode. Okay, now we come to the working principle of ASI. First is the master slave and asset technique. The ASI network has only one master which controls the data exchange. This will pause on ASI slaves and wait for response. Secondly, about the electronic address setting. An ASI slave identifies address. This only occurs once within an ASI system. The address setting can be done by using address unit or setting on the ASI master. The address is always stored permanently on the ASI slave. The factory address of ASI slave are 0. The third one is operating reliability and flexibility. High operating reliability so as the master monitor the voltage on the cable and the transfer data. It detects the transmission errors, the failure of the slave, and send a message to the PLC. And from that, the user can take action for this message. In case we replacing or add in SI slaves during normal operation, it will not affect to the communication with other SI slaves. Okay, next the masters and slave principle. The process data and the parameter assignment command are transferred via the interface between the master CPU and the SI master CP. You can see here. And the user program have a suitable function, calls, and mechanism available for reading and writing via this interface. And the information is exchanged with the ASI slave via the interface between the ASI master CP and the ASI cable here. It's meant here. Okay. So what is the function of the master? The ASI master specification distinguish the master with the different range of the functions known as a profile. M0 to M2 for standard master and M3, M4 for extended master. Okay, we will go to detail of each profile. The master profile M0 Master can exchange the I/O data with the individual SI slaves. The master is configured by using the station configuration found on the cable, known as the expected configuration. The profile M1. This profile covers all the functions according to the SI master specification. And this is the M2, the same as profile of M0. But in this profile, the ASI master can also assign a parameter to the SI slave. And this is M3, the same as profile M2. However, here complex slave can be assigned parameter by SI master and 16-bit input or output. And the final one, M4. Same as master profile M3, however, expanded by ability of the SI master to assign the parameters to the combined slaves. Transfer of series data, extended address mode, 16-bit input in the extended address mode, and fast or super fast analog value transfer. Okay, next we will go to the function of the slave. The first function of slave is connecting to the ASI cable. The ASI slave has an integrated circuit we call ASI chip that provides the attachment of an ASI device, can be a sensor or actuator, to the common bus cable to the ASI master. The integrated circuits contain the following components. First is configurable data inputs and outputs. Second, 4 parameter outputs. Third, 2 analog channel, 16-bit. The operating parameter configuration data with I/O assignment. Identification code and slave address are stored in the additional memory, for example EEPROM. The second function is about the I/O data. The data for the PLC that we transfer from the ASI master to the ASI slave are available at the data output. The values at the data input are made available to the ASI master when the ASI slave is born. The third one is a parameter. Using the parameter output of the ASI slave, the ASI master can transfer the value that are not interpreted as a simple data. These parameter value can be used to control and switch over between the internal operating mode of the sensors or actuators. For example, be positive to update a calibration value during the various operating phase. And the next one is about the configuration. The input or output configuration indicates which data line of the ASI slave are used as input, output, or as a bidirectional output. The I/O configuration for bits here can be found in the description of the ASI slave. In addition to the ASI configuration, the type of SI slave are described by an identifier code, and with the newer SI slave by 3 identification code here: ID code, ID1 code, and ID2 code. Next, how the data transfer in the SI network. The following schematics show the system component in which data field and list of the system are stored. Here, okay, I will show pointer. Firstly, we focus on the data image here. These contain the temporary stored information. First, I will talk about the actual parameter here. Parameter. They are an image of the parameter currently on the SI slave. And the actual configuration data here. This is the data field contain the I/O configuration and the ID cost of unconnected SI slaves once these data had been read from the SI slave. Next one is about the LDS here. LDS stands for list of detected slave. The LDS specify which SI slave were detected on the SI bus. And next one the LAS here. It stands for list of activated slave. Specify which SI slave were activated by the SI master. The I/O data are only exchanged with activated SI slave. Okay, and the next data is I/O. This is the process input and output data. Okay, next one we will go to the configuration data here. These data are stored in the EEPROM, which are available unchanged even have an hour failure, have an power failure. First is expected configuration data. These are selectable comparison value which allow the configuration data of the detected SI slave to be checked. Next one is about the LBS stands for list of permanent SI slaves. This list specify the SI slave expected on the SI cable by the SI master. The SI master checks continuously whether on the SI slave specified in the LBS exists and whether their configuration data match the expected configuration data. And this is the data on the SI master here. Next we come to the data on the SI slave. On the SI slave we have the I/O data here, we have the parameter, and we have the actual configuration data here. This is the configuration data include the I/O configuration and the ID code of ASI slave. And the final one is address. The ASI slave have address 0 when installed. To allow a data exchange, the ASI slave must be programmed with addresses either than 0. The address 0 is reserved for a special function. So this is the data transfer. Next we come to the operating phase. You can see this jack here. First I will talk about the initialization phase. The initialization here, also known as the offline phase, sets the basic status of the master. The module is initialized after switching on the power supply or following a restart during the operation. During the initialization, the image of all the slave inputs and the output data from the point of view of the application are set to the value 0. It means inactive. After switching on the power supply, the configure parameter are copied to the parameter view, so that subsequent activations is with the preset parameters. If the ASI master is reinitialized during operation, the value from parameter view, which may have the change in the meantime, are retained. We come to next phase. This is the startup phase here. In the startup phase, we will separate. The first phase is detection phase. Here, detection of the SI slave in the startup phase. During the startup or after a reset, the ASI master runs through a startup phase. During it detects which SI slave are connected to the SI cable and what type of these slaves are. The type of the slave is specified by configuration data stored permanently on SI slave when it's manufactured and can be queried by master. Configuration file contain the I/O assignment of an ASI slave and the slave type, or we can call ID code. The master enter the detected slave in the list of detected slave, or the LDS I mentioned in previous information. Next phase about the activation phase. After the ASI slave are detected, they are activated by the master sending a special code. When activating individual station, a distinction is made between two modes on the SI master. The first mode is configuration mode here. On detected station are activated. In this mode, it is possible to read the actual values and store them for configuration. And the second mode is protected mode here. Only the station corresponding to the design configuration stored on the SI master are activated. If the actual configuration found on the SI cable different from this design configuration, this is indicated by SI master. The master enter the activated SI slave in the list of activated slave, or LAS. And next we will have the phase data exchange phase here. This is the normal operation. And we come to the management phase, and the final phase is inclusion phase here. After the inclusion phase here, we come back to the data exchange phase, and we do the loop here. Okay, that's the operating phase. Next, we will go to the interface function. In order to control the master or slave interaction from the user program, there are some function available on the interface. The first function is read and write. When writing, parameters are transferred to the slave, and the parameter image on the CP here. When reading, parameters are transferred from the slave or from the CP parameter image to the CPU, to the PLC here. The second function is about the read or store configuration data. Configure parameter or configuration data are read from the non-volatile memory of the CP. The third function here, this is the configure the actuator. Configure actuator. When reading, the parameters and configuration data are read from the slave and stored permanently on the CP. When writing, the parameter and configuration data are stored permanently on the CP. And the final function is supply the slave with the configure parameter. Configure parameter are transferred from the non-volatile area of the CP to the slave. With the diagnostic compliance slave, diagnostics data is also read from the slave when parameters are read. So it's done for the SI network introduction. Next, I will show you how to program for an ASI network. Okay, we open the TR portal and create the new project. Here I will put the name here, ASI1. Create. Next, I will configure a device here. Add new device. I will add PLC S7 1200. Here I will select the model here. Okay. Add. Okay, we come to device view here, and firstly we will insert an SI master module. We come to communication module here, come to AS interface here, and we grab and drop it here. This is the module CM1243 and 2. This is the ASI master. And next we come to network view here, and inside the slide, this means the I/O module. We come to field device, come to AS interface here, and I will select the input and output module IP6. Okay, firstly I will input digital input here. For digital input, we write here. No, okay, we select the module. Okay, wait for it. This is the slide with 4 digital input. Okay, next I will select the module output. Also for digital output here. Next I will select the analog input first. I select 2 analog input here, and output. Okay. Next, I will connect the I/O module into the PLC via SI master. Click here and right here, and we do the same for remaining module. Okay, so it's done. Next, I will rename for the I/O bins. Here we right click and we right click here, and we select property. Come to the I/O tabs here. For example, this is the digital input. I will for the address 2.0. I will rename the tag is stack. I will create the tag for control a basic motor. Stop. Here, this is the input, and we come to output here. The output. Okay, this is the output. I will name is motor output. Okay, and similar with the analog input here, we can select we can type the tag name here. For example, temperature 1203, and the output here can be a control value of the control valve 1202. This is the CV control value. Okay. Next, I will set in address for slave. We come back and we come to the general tab here. Address, I/O address. No, AS interface here. We come to the AS interface address here. For the first slave, I will let default 1A, and come to next slave here, 2A. Okay. Next slave here, 3. We can select OK, and next is 4. Okay, so that is done for the address for slave. Next, I will program for basic program. We come to program block here, add new block. Okay, basic motor. Sorry, we deleted. Add new block, db, op, basic motor. Okay. For the basic, we will have one stack here. Stop here. Oh. The motor. See. Okay. This is a stack with stack here. Okay, it's automatically link the tag we define on slate. It's the same with the stop here. Okay, and this is the motor output, and this is the motor output. Okay. Next, I will stack simulation. Okay. Switch to project view. Load. Finish. We need to create new project, example project 7. Okay, we come to the sim table. Wait for it. Come to the sim table 1 here. We click on the load project task. Okay. Now we come back to the program. We monitor it. And we open the PLC sim here. For example, the stack bit. Okay. If you click on, you can see we stack. So it's done for programming a basic ASI network. Thanks for your watching. See you in the next video.